Today we will be looking at transforming functions. So the function we're going to use for today's lesson is going to be x squared, a quadratic function. But these rules for transforming functions will apply to just any function that you're going to use ever. So the first thing we're going to look at is horizontal translations. So we want to figure out how we can take this graph, move it horizontally, and then write the equation for it. So if we take this graph and move all of these points 3 units to the left. So our point negative 1, 1 will become negative 4, 1, 0, 0, negative 3, 0. If we do that for every point that we have here, our new function ends up looking something like this. So how can we write that as its own equation? So if we make an XY table for this new graph, what we did to all of our x values was subtracted 3 from them. So this negative 3 will now become a negative 6, negative 2 will become negative 5, negative 1 is negative 4, and so on. So with that, all we did was change our x's. None of our y values changed, so we can just bring all those same y values over. So if we look at it, none of our y values changed, right? So now we need to figure out how we can write a function in terms of our old function for this translation of 3 units left. So we know it's going to be a quadratic just like before because we have a parabola. And we know that these y values that we have for either one of these functions come from squaring these values. So we have the same shape of graph here, and we need to basically plug these y values or get these y values out of our function, which means that we need the function to see us putting these in there. But the trick here is to put in something different and change it that way the function sees these values that we want to plug in. So the way we got to these x values was by subtracting 3 from all of these. So now we want to be able to plug in these x values and get these same y values back, either these ones or these ones because they're the same. So if we look at it, negative 3 is what we want the function to see, that way we get a 9. But we want to get 9 when we plug in negative 6. So what we have to do is plug in the x value that is 3 more than the x value that we want. So if we plug in negative 6, we want the function to see 3 more than negative 6. That's what the function is going to see and actually use. That way the function thinks that we're plugging in negative 3, and it'll spit out a 9 for us. Same thing with our negative 5 here. If we add 3 to it, the function sees a negative 2 that we're plugging in and spits out 4. That way we get the same y value back. So x plus 3, f of x plus 3 is going to shift your graph 3 units to the left. So keeping with our horizontal transformations, next we're going to look at horizontal stretches and compressions. So again, we have the graph of the function f of x equals x squared. And what if we wanted to do a horizontal stretch by 2? So we're going to take all of our x values and multiply them by 2. 0 is going to stay at 0. Here we have the point 1, 1, so the x value is 1. Our new x value will be 2. Same here, would be negative 1. So our new x value is going to be negative 2. Here our x value is 2. It'll be stretched out to 4. 3 will be stretched out to 6. And here we have negative 4, negative 6. So our graph of this new stretched function is going to look something like this. So if we do an XY table with that, we have all these old x values that we had before, and all we did was multiply every single one of them by 2. So negative 3 is now negative 6, negative 2 is negative 4, negative 2, 0, 2, 4, and 6. And just like before, if we notice, none of our y values changed. We still have the same y values got stretched horizontally to the same y values. Since we're doing things just horizontally, nothing changes with our y values. So we'll have all those same y values as before. But just like before, how we kind of tricked the function into thinking that we were plugging in these original x values, but really we were plugging in what we wanted. We need to kind of do an adjustment here. That way the function thinks that we're plugging in these old x values. So to get from this negative 3 to this negative 6 with the stretch, what we did was multiplied by 2. So if we're going to start out here with the x values we want to plug into our function, and we want the function to see these x values, that way it spits out those same y values, then we need to take our x value and go backwards. We need to divide it by 2 to get from negative 6 to negative 3. That way the function thinks we plugged in negative 3, and it spits out 9, like we're supposed to get with our new function. So what that's going to look like is our new function will be f of 1/2 of x. If we take this 1/2 of x, 1/2 of 6, now the function thinks we plugged in negative 3, and we'll get 9. So this is the same process you'll use if you want to do a compression as well. If we want to shrink our graph horizontally, let's say we wanted to shrink it by 2, shrink it in half. So it'll look something like this. Our new x values are all 1/2 of what they used to be. Here our x value is 1, sorry, right there. Our old x value was 2. So what we would do is make it be f of 2x, because it's going to take the x values that we're plugging in for this function, 1, our x value that would be right here on our new function. If we multiply it by the 2x that we have here, then it thinks that we're plugging in negative 2 right here. But since it thinks that we're plugging in negative 2, it'll spit out that same y value. And if you do that for every single point, it'll shrink you in. And this is the same thing that we would use for reflections over